Hello and welcome to another episode of MLOps Coffee Sessions. I am here with Dimitrios, who just popped back in after checking in on something in the oven. And
What's happening, everybody?
and today our guest is Dave Bergstein, the head of product at Pinecone. And funnily enough, an old colleague of mine. So you guys are here, going to hear a lot of, just general shooting the shit. And Dave, thank you so much for joining us. We're very excited. I'm very excited to have you on the podcast.
Happy to be here.
Yeah, thanks. And so, you're now the head of product at Pinecone. Congratulations. You guys recently came out of stealth and have been really talking a lot about the interesting applications in your product space. And I'm excited to dive into that. And Dimitrios is too. And
cool.
Before we get there, I'd really like to start by hearing about your background and how you got to where you are today at Pinecone.
Sure. Yeah, I've followed my curiosity and interests to some different places along the way. I was reflecting that I wrote my first neural net in undergrad in C++, studying electrical engineering, and it was for a mining application. It was for a motor. And I'm not sure that the motor went into use. It was, again, to go deep into mines, and they needed a better controller. And the neural net seemed right. So it was a single neural net with a hidden layer, just a few nodes. And I wrote it in C++. I read papers on backpropagation and how to implement it. And if it did get used, I would say that was my first model in production. But I'm not sure that the motor ever actually went into the mine. Well, no one ever knows. Maybe I should follow up and find out whatever happened to that. But yeah, so I studied electrical engineering, and I, immediately, it's funny, working on a motor and a neural net, I followed the motor path. I went into power electronics. And so I worked at Lutron Electronics for just a little over a year doing circuit design and manufacturing. But followed interest back to grad school, and was at Boston University. I intended to study power electronics, but optics was all the rage there at the time, and I just kind of got pulled into that, and ended up getting my Ph.D. in photonics within electrical engineering, and then saw an opportunity to take what we had in the lab and start a company with it. So we sold an instrument that was looking at proteins and looking for proteins in blood samples. And it was a great venture. I mean, it was 3 years. It didn't end in success. It failed. But I think me and the few people working on it learned a lot along the way. And so then I went into engineering management. But I think maybe my two things that I think, one, I realized that I like being in product. And so after being an engineering manager on optical sensor development, I moved over into product management at MathWorks. And I'll say that, neural nets and maybe AI have always been there in the background to some extent, one, going back to the motor and the controller for it. And then even when I was working in optical sensors, there was a need for machine learning. So we used a support vector machine. And so I worked on developing that. And then that did go into production in their optical sensor. And then at MathWorks, as product manager, it was like the boom in AI, all things machine learning and deep learning and neural nets, and it just exploded. And I was there for that, and then moved on to Tesseract, where, as you know, we were putting ML into production. And now here at Pinecone. And yeah, I've been in product for the last, number of roles.
Got it. Yeah, at Tesseract, we're trying very, very, very hard to put ML in production, as everybody that's listening to this podcast knows. I'm asking for a lot of help from every guest speaker that comes on. Your journey, it sounds a lot like what I think many of the people that are on the podcast may have gone through. I think, like me, studied a non-CS form of engineering, had some experiences, and over time, as the software boom and this machine learning sort of field has opened up, have transitioned into the field. And it's sort of interesting to hear that reflected in your experience as well. How do you think that kind of shaped your approach to building software products and thinking about software products, your experience in the photonics world, in the hardware world?
Yeah, one experience that I definitely think about as you ask that question is manufacturing. And that was my first experience. And production maybe had a little bit of a different meaning. It was an assembly line and workers and robots assembling. We were doing, it was ballast, electronic ballast for lighting. And so we were producing about 100,000 units a year of the product I was on. Overall, that factory was producing millions and millions of products each year. And, I think that shaped in many ways how I think about engineering and also production, and taking something as a prototype and bringing it forward. Even though it was physical devices and electronics, there are parallels, right, and analogies to what it means to build something that's robust and, reliable and at scale. I don't know if that helps answer.
No, it totally does. It totally does. That the reliability, one thing that, I think pulling from the famous book, Designing Data Intensive Systems, we always talk about the reliability, scalability, and maintainability of data intensive systems on this podcast and on the Slack and in the community, because that is the challenge that all of us as a community of practice are facing. And I love to hear the experiences of guests from their time outside of the ML world, because those are problems that have been thought about very deeply in other engineering realms. The maintainability and scalability and reliability of the New York City subway was thought about very hard in the 1920s. So there's something to learn about, from all of these different realms. And so I think you answered the question in a spot on way.
Yeah. One thing, as you bring it up, I'll mention, I still remember as I was young engineer, our product had about 200 electronic components, discrete, resistors, capacitors, FETs, inductors. Anyway, the quality person took all 200 and put them in a bucket or something and showed it to us and said, consider all the different combinations of the ways that these interact. Think about the fact that, each one has a tolerance on maybe 5 different things. So you take 200 components and maybe they have 5 important attributes each, and then they each have a tolerance. And then think about the combinatorics of how they all could combine in different ways to lead to potentially strange edge cases and weird phenomena. And in some ways, when you think about the software systems, it's not so dissimilar. We have to consider that it becomes incredibly complex, and all the different ways that a system can fail become incredibly numerous and complex. And then you have to think about the ways that you test. Yeah. Something cool to think about.
Yeah, absolutely.
That's so cool.
The testing piece is the part that gets me.
Yeah.
As it always does.
A lot of people.
Yeah. So now that, I think we've all gotten a little bit of sense of your experience so far, I'd love to talk a little bit more about what Pinecone is doing. Can you give us a little bit of intro into what you guys are building and why it's so exciting?
Yes, similarity search at scale. We are doing vector similarity, and we provide it as a service. It's a managed service for doing vector similarity. And the reason this is important is coincides with the advent of neural nets and their ubiquity, and the fact that also people are increasingly relying on pre-training, right? I mean, you train, or maybe tune a neural net, and then at that last stage, you can take the outputs, you can treat that as a vector, and then you can do all sorts of things with that vector. And one common thing is to look for similar objects or dissimilar objects. But of course, that's just the start. One of the places that this comes up frequently among our customers is, BERT, right? I think maybe listeners are probably familiar with BERT, the language model, and the fact that you can have BERT trained and produce a vector that captures some of the semantic meaning in that sentence based on how you trained the model. And then you can think about having, millions or billions of these vectors and looking for items that are extremely similar or dissimilar. And, looking for similar vectors, it can be, pretty basic, you might think, at a small scale on your PC, right? But when you want to do this at scale in a very large way, it actually becomes challenging and complex. And so we do it approximate, and there's good libraries for that. But then you want to take those libraries and scale them. And then you want to build out all the kinds of things you kind of expect from a database around those libraries. And that's where we come in to help you be able to put similarity search into production in a way that you can rely on it and have the performance you expect.
So for those of us who aren't so familiar with vector search, can you break down what exactly that is?
Yeah. So let me think. I guess the way I think about it is reducing it, whether it be an image or text, to some set of numbers that capture the essence of that text or the essence of that image. And it could be as simple as traditional features, right? Maybe image processing features like corners or, color or, some other attribute. But neural nets provide a great way to reduce it to a set of numbers that actually carry some meaning. And, to give an example, I often give a demo. As Vishnu knows, I have a dog, Zeus, that I love. And I think he's cute. So I take his picture and I go find his brothers and sisters, I call it, on the internet. And what I do is I go to Flickr, I download, thousands of images, and I find the image that most looks like him. And what I did to do this was I took the picture of Zeus, right? And I passed it into a neural net that was trained to identify the difference between animals. It was trained to identify dog versus cat versus bird versus elephant, right? And so this neural net was trained to do that classification based on images. And I break apart the neural net, if you will, and I take the last fully connected layer. And that last fully connected layer is, a bunch of numbers. It's 1,000 numbers, approximately 1,000. And those numbers capture in some way the essence of what Zeus, who Zeus is, insofar as the neural net was trained to distinguish cats from birds, from elephants, from dogs. It captures what makes Zeus different than those other animals. And that representation, those 1,000 numbers that, capture what's different about Zeus from those other animals, turn out to be very good at also finding other dogs that look like Zeus. So if the numbers are close, then it's a good chance that the dog looks a lot like Zeus. And if the numbers are distant, it's a good chance the dog doesn't look like it, or maybe it's an elephant, right? And when we say that the numbers are close, then we get into, okay, how do you measure close? And that's where we get into vector geometry. And we think about, you can do the Euclidean distance, you could do a dot product distance, you could do a cosine distance. And these are all just different distance metrics of how we say that two sets of numbers are similar or dissimilar. And in that way, we find, I used cosine. No, I didn't use cosine. I used dot product similarity. And I found the vectors closest, and they corresponded to dogs that looked a lot like Zeus.
So I like the Zeus example a lot. I also had a dog, and I've had many great memories with the dogs that I've had. What are some other examples of this being used?
Yep. So text is definitely a big one. But actually, going back to images, so one customer we're working with has a networking platform. I don't want to name it, but they have we could say tens of millions of images of people, and so they want to find. In this case, they want to find people that look very similar, because it's an indication that maybe the same person is popping up in multiple profiles, which would be, not wanted. And so that's an example where they want to find images that look people that look very similar to other people, because it could be that it's the same person, right? Another example, though, a lot of our examples come from text. And so converting a sentence into, actually, one more on images, e-commerce, finding products that look like other products, right? Recommending products that look like other products.
Oh,
text
interesting.
Yeah, so recommending systems, systems that recommend products. Text is very big. So if you type a sentence, right, and you want to capture the meaning in that sentence, and it could be that you're looking for, maybe again, go to shopping as an example, and you want to type in exactly what you want to find in terms of khakis, right? And you describe them, khakis that are a little light, they're soft, they're something else. And we want to capture that and then find the products that most match your sentence, right? That most match what it is that you're looking for. And so we can look across millions of products. Better yet, we can look across millions of products, and we could also look across, if each one of those products has maybe hundreds of reviews, maybe we look at all the sentences and all those reviews to find something that was, say, good for the office. If somebody says, oh, this was perfect for the office, I wear it every day to work, right? That's the kind of thing that we want to capture and be able to return and say, you're looking for something in the office? Well, a whole bunch of people said this is good for the office. Or maybe they didn't even use the word office. They said it was good for work, right? And you said what's good for the office. But when you capture the meaning, kind of like you capture the essence of what Zeus looks like, when you capture the semantic meaning of the sentence, you can realize that something good for work and something good for the office are actually the same thing, and return that.
Does this also help with translation?
Yes. We haven't used it for that, but people definitely use these language models for translation. And I want to maybe clarify that this isn't so, in some ways it's emerging and very new, but this is something that Amazon, Google, others have been doing. And so this is very popular among the very top, again, Amazon. You search something for Amazon, I think everybody realizes that Amazon does an amazing job at getting you the relevant items that you were looking for. Google does the same. And so the issue is that a lot of companies haven't made that step yet. And so if you go to a lot of e-commerce sites, they don't have the ability to get you just what you want the same way that, say, Amazon does. So I just wanted to clarify that it's not, people have been doing this. Yeah.
No, that makes a ton of sense, because if you think about it, the notion, it's funny that you I think the way you're kind of putting it almost is that this is new, but it's not that new, but it's new,
Yeah. Yeah.
In the sense that, thinking about your data, whatever forms of data as vectors, as embeddings, is not necessarily novel in the machine learning world. It's still, there's still a lot more run that trend has to have, but embeddings and vectors are, with word2vec and with just, the understanding that, a string of numbers can represent, something through sort of data compression and through, tools like principal component analysis and whatnot, that exists. But it sounds like what your tool is enabling people to do is apply that where in past cases they have not necessarily had the engineering ability to be able to handle the large quantities of vectors and the calculations. And I think, correct me if I'm wrong, but it sounds like a lot of e-commerce companies are probably serving recommendations through just basket analysis and saying, through, run a SQL query and say, oh yeah, customers like you that bought a pair of jeans also bought a white t-shirt. When who knows, maybe it's a belt.
No, thank you. That's spot on. And so maybe I can characterize a common scenario that we run into like every day, it feels. And that's that a company comes to us, they've been doing traditional search using Elasticsearch, right? For example, and they have a data science team. And the data science team has been working with embeddings and neural nets and shows them what's possible. And they get excited. And then they say, great, let's go put this into production. And the data science team says, okay. And then they start building something with the DevOps team or the MLOps team. And they quickly realize how difficult and expensive and challenging it is to do at scale. And then that's when they turn to us. And then we come in, because we don't do the models, right? We kind of necessitate that the customer has a model, or we can connect them to somebody who could help with the models. But in many cases, they have a data science team. They do have models and they do have embeddings. They struggle to take those and put it into reliable use in production at scale. So thousands of queries per second, or tens of millions or even billions of vectors. They can't do it on their PC anymore.
So I guess I would like to go deeper there on some of the engineering challenges associated with vector search that you see companies grapple with, right? As you said, story as old as time. Data scientists get excited, company gets excited, engineers are like, wait, we can't maintain this. But I'd like to understand in what ways that maintenance or that engineering challenge presents itself. Because to me, maybe I'm the data scientist that's the problem, but I hear embeddings or strings of numbers, they can't be that long, and each individual embedding is probably a lot more efficient and smaller to store than the raw image itself. And we have companies that are storing millions and billions of images. Maybe they're creating them with tags. So what exactly are those engineering challenges that the companies find?
Perfect question, right? And maybe I'll go back to my Zeus example briefly, because when I was actually interviewing with Pinecone, I've only been with Pinecone 3 months now, and when I was interviewing with them, I actually did the Zeus example. It occurred to me looking at my dog, and
so this
the
is
first thing
this is like your bit.
Yeah, maybe you can send us a picture of Zeus so we can superimpose it on top for the people that are watching on YouTube.
I will do. And the first thing I did was I fetched 100 images first, and I just did it brute force. It's a matrix operation to look at distances. I did the dot product. It's pretty straightforward. And it actually ran in like milliseconds. It was crazy fast on my Mac, laptop. But then when you go to larger, the moment I went to thousands, it slowed down significantly. And remember, these are applications. We're talking to people who usually need latencies that are pretty low for like responsiveness on websites. Something like 100 milliseconds is common. We've gone down to 10 milliseconds. We do 5 milliseconds. Point is, waiting 5 minutes is not in the cards. That's not what they're looking for. So that's when you have to move into approximate nearest neighbor, and you want to get good results within a fast amount of time. And there are algorithms for doing that. The top algorithm is FACE. FACE is from Facebook. Facebook uses it. So another example of a big company using this technology, and they really innovated in the development of FACE, which is the top library out there. There are others. HNSW is a popular algorithm. Now it's part of FACE 2. There's SCAN. But the next challenge then is, okay, so you move into using one of these open source libraries that has a very efficient algorithm, but most people are still doing it on one machine. And there's a limit then. If you have a small number of vectors, maybe 10,000 or 100,000, something small, maybe you can get by doing it, on one machine without huge scaling issues, right? Using one of those algorithms. But when you want to go larger, here's where you run into trouble. You want to start thinking about Kubernetes. You start thinking about having multiple shards and replicas like a traditional database. Also things in production, even in the small case, even if you could do it on your one laptop or one machine, I think of laptop because that's what I use, but you still want database operations, the traditional CRUD operations, to be able to create, read, update, delete. You want these kinds of things that aren't necessarily included in the open source libraries. And then when you think about scaling and you think about shards and replicas to try and put this onto many machines, there are a host of complexities that people kind of run into that kind of run against maybe some of the production needs, that you want things like persistence. If things go down, you want fault tolerance. You want it to be eventually consistent. And then how do you handle updates? Updates is a big one, especially when you have a system that's running live and you want to be able to update it live as it's running. And then to your question about size, you're right. The images are huge relative to the vector representations. But a catch here is that to search over all the vectors, you want them in RAM to do it fast. The fastest way to do this is to keep all your vector data, not necessarily the images, but the vector data. Yeah, not the images. The vector data, you want to keep it in RAM so that you're very fast and responsive to get these low latencies. And RAM is expensive. And so as you start to think about, there's trade-offs there as to, can you reduce the size of your vector to save on the cost of RAM? And at first, when I came into this, I thought, isn't RAM cheap? But maybe people are laughing if they realize that, no, it's not cheap. It's costly. And when you talk about billions of vectors, cost of the compute in the cloud gets to be a significant factor. And in often cases, it's one of the biggest factors. And so these are the kinds of things that, thinking about ML ops, we know how to handle and we know how to optimize. And that's where I think the data scientists working with their internal ML ops team or their internal DevOps team haven't spent the amount of time that we have thinking through these problems and how to solve them and optimize them.
That was a very thorough and very helpful answer, because I think, the challenge that I didn't comprehend, and I think a lot of people might not comprehend when they get into this, is that the use case is what makes the engineering so challenging, right? And that is the thing that I didn't necessarily connect. This vector search has to happen quickly. It has to happen over large amounts of vectors, and it needs to happen in a way that's like engineered in a way that's sustainable, right? And that is the essence of the challenge. It's that, if done correctly, vectors can be very useful to a particularly important set of challenges that modern businesses face. It's just that engineering correctly part is hard for the reasons that you've elaborated, right? That speed, that scale, and the fact that this isn't a problem necessarily, even with the search algorithms that people are necessarily super familiar with, right? I mean, vector similarity, to me, there are some algorithms in sklearn or some some functions in sklearn that I can use, but it's not like I was ever taught to think extremely critically about vector search and are familiar with a number of different algorithms. That's not that's not a skill set I possess. So I can see how Pinecone can help me with this problem space.
Yeah,
I'm wondering about, because you mentioned how hard it is with updates, and do you also find security as a big challenge?
Absolutely. So that's another key value that we bring. And when I say updates, I should clarify two types of updates. There's updates of the vector data, right? Or metadata around the vectors. And then, of course, there's software updates. And so I'm glad to say that we can handle both gracefully. We have different engine types that we support. We work with FACE, the top algorithm, or the top library, I should say. We work with HNSW, and we also have our own proprietary, our own proprietary engine. And there's trade-offs there. So that our own proprietary engine, we can update live in tens of milliseconds. We can update vectors, and we can build the entire index, we call it, from scratch very quickly, faster than we could with FACE or, say, HNSW. But then there are other advantages to those other engines. And so, for example, HNSW can be a little bit more challenging to update. You can add vectors, but if you start updating it's based on a graph method, and it can kind of disturb the graph. And so that's the kind of thing that we realize that challenge. We know that our customers want to update their data. And so we built the machinery to, seamlessly swap in new vectors and basically new indexes as necessary. And then also the same goes for software. If we want to update the software, we can use a lot of the same machinery that we can use for updating indexes to actually update a lot, through Kubernetes on the fly. And that's something that, we also are very cognizant of. And certainly security is paramount. We have a number of different ways of working in different environments. I would say that the common way of working has been using if you're familiar with AWS Private Link. So we run things we can run things on GCP or AWS, and taking AWS as the example, we run it in a separate account on AWS on our side, and then we use Private Link for the API to do the queries from their system. But yeah, we absolutely spend a lot of time on security.
Got it. I'm glad to hear you guys are. I think many of the people in the community are thinking about this challenge around security, and we've had a couple guests, and always helpful to hear how different companies are thinking about it, that aren't necessarily, security vendors themselves, because, it's a really practical challenge that the entire industry is facing right now. I kind of want to shift gears a little bit and, talk a little bit more about the sort of MLOps ecosystem more generally, ML tooling, and get your thoughts on it. And my first question on it is, you and I crossed paths at Tesseract Health, which was building was and is building an affordable portable imaging device. And Tesseract is a company that uses ML to enhance an existing product. After Tesseract, you joined Pinecone, which is a company that's building or enabling the use of ML for other companies. And I'm kind of curious, how has that switch been for you as a product professional, as somebody that, kind of had a perspective on, how to use ML in one use case, but now has to think about it in many use cases?
Yeah, it's been great in the sense that I feel like I can feel some of the pain of our customers, right? In fact, some of our customers sometimes we are selling to like the product person. Usually it's the MLOps team, but in any case, I know that I felt the pains myself. We both did. You and me both, we felt them at Tesseract, and we knew that our business objective was to get this into production and into use and to get it cleared by the FDA. And our objectives were not about, that was our end objective. We weren't a tools company in that sense. And so we were deciding things about what to build ourselves, what not to build ourselves, what to rely on others for. And I think that experience helps me now connect with our customers who are often facing the same questions and challenges. I mean, some people do want to build things on their own, and that's great. I think I saw from Tesseract how painful it can be to try and build some things on your own, and sometimes the opportunity cost that gets missed. And so I know that intuitively, right? Not intuitively, I know it viscerally, right? Because we felt it.
Yeah. Oh yeah, we felt it. As everybody has heard on this podcast. That makes a lot of sense. I mean, taking that, understanding that empathy and applying it, to the development of an MLOps tool is really powerful. And I want to ask about another one of your experiences at MathWorks and helping build MATLAB, because I think a lot of the listeners on this podcast will have used MATLAB in their college days or in their research days. It's an OG, and it continues to be. And if you think about, we talk a lot about platforms. MATLAB and what MathWorks provides across its product suite are platforms for scientific computing, right? Designed to enable a wide range of professionals. How has that experience, working on MATLAB, shaped the way that you perceive building modern ML tooling?
Yeah, it shaped it in huge ways. I'll say that MathWorks and MATLAB have a very special place in my heart. I love them dearly and could probably talk on and on about MATLAB and MathWorks. And one of the things I want to point out to people is that a lot of people know MATLAB from their education because it's very common in schools. But most of their business is industry, and the big industries are auto, aerospace, defense, biomedical device, finance. So they're in all kinds of industries. And, some of the ways they get used heavily in, say, auto is that they have products like Coder, that the Coder line of products that basically can take MATLAB or Simulink and generate code that runs on the different microprocessors that end up in this big machinery, from tractors to trucks to helicopters. And so a lot of these, all these companies are pretty much using MATLAB and Simulink to some extent. And then when I was there, what I saw was really this advent and transition into machine learning and deep learning. I mean, it was just huge how it kind of exploded overnight, or over several years, I suppose. But I saw many of these traditional industries struggling to adopt. And what we were seeing was that we were selling tools for, we had our machine learning toolbox, the deep learning toolbox. And this is where a lot of data scientists kind of gravitated, especially in the early days. And they were using our tools. And then how that fits into this idea of productionalizing it. Like, how do you take it and put it into maybe a helicopter, right? Or a car, or some other type of, big machinery. Or I'm just using that as one example because it was kind of characteristic of some of the customers I talked to that were in these more traditional industries that, and there was this, interface between the new data scientists that they were bringing on and the production engineers. And a lot of times those production engineers were DevOps, right? And so a lot of times I found myself in conversations with the same people who do the CI/CD pipelines. And so, people who were working on the CI/CD pipelines were all of a sudden also thinking about, okay, how do we get this model and get it into our system in a way that it's tested and robust and we can depend on it. And it was a great experience working through those questions and discussions and problems with customers. And I think now it's matured. I think, early days was I'm talking to the CI/CD team.
And as you've been on the inside and you're coming from product, I think it's fascinating to look at what do you feel are some of the reasons that it didn't catch on to the greater MLOps audience? Like, what is a reason that it's not hugely used like it is in the university setting?
So I guess I want to challenge hugely used because obviously it's not the predominant tool. That's our customers at Pinecone many of them are using Python or Go as their tools of choice. But MATLAB and Simulink are used widely in universities because MathWorks prices it they really make it a good deal for the universities to adopt. And it's kind of like a way to get it out there and get people using it, right? The industry is where they make most of their money, and the industry use has been steadily climbing. And so while it didn't catch maybe the huge wave, to take over the world, it's hard to argue with success that their numbers and revenue and number of users and number of applications have just steadily grown. And I think they have their niche within the types of customers that they've often served, the types of industries, the places that they've often been. And so, maybe it's not the e-commerce that, Pinecone, we deal a lot with e-commerce. It's a different type of customer, but I think that MathWorks and MATLAB has had success within within the scope of who they were targeting.
Yeah. So I want to dive one level deeper in the, in the engineering or the creation of MATLAB, sort of, as I described it at the top. It's a platform, right? As you said, as you mentioned, you were talking to CI/CD teams, and also data scientist teams were also using it to power their particular computations. And it's a platform that is very deep, that has substantial depth for, all those different kinds of professionals. In the current MLOps ecosystem, a lot of companies are building out platform teams. A lot of companies are building their own platforms or are buying platforms. coming from, one of the original platform companies for scientific computing, what lessons do you think companies that are trying to create their own sort of ecosystems can learn, to support that diverse, variety of professionals from the sort of MATLAB and MathWorks experience?
It's an excellent question.
I think about it a lot because, I'm really interested in this idea of, platform. If I had a dime for any time, I said the word platform, I'd be a trillionaire. But I think about it a lot. We've had on guests that, talk very persuasively about the idea, Pablo from booking.com, where they have a very famous, sort of team working on these things. And I'm curious on just what the lessons are that, you can share.
Yeah. So one thing I think of when I think of platform is interoperability with other platforms. And where do you draw the boundaries around what you want to be in your platform and what are you going to accept as not part of your platform and what are you going to operate with, if that makes sense. And I think, in MATLAB's case, and I have my own views, which I want to, these are my views. Namely that, there was a book, The Cathedral and the Bazaar, or The Bazaar and the Cathedral, about open source. It was written like maybe 20 years ago or longer. It's an older book. And they actually used MATLAB as a shining example of all the whole ecosystem around it and all the people who were building tools on top of it to do other things other than the platform itself. It was that platform that lots of people built lots of things on top of. And I think that, openness is a great way to achieve that. And I think that there also comes a time where sometimes bringing a lot in-house can help you improve performance and can help you do things even better. And that happened in some ways with MathWorks. They brought in some of the toolboxes under the MathWorks umbrella and were able to improve their performance and make them, operate even better, add more features, add more consistency and actual performance in terms of execution time. But then, it's a trade-off and there are advantages to enabling a whole ecosystem around your platform and ways to operate with other platforms. And I think that's something that some of the, like, if you look at, Python or some of the other tools that are out there now, there is something to be said for that interoperability. Now, I'll say MathWorks has a lot of interoperability, but you asked what helps success or what hurts success. I'm a big fan of that interoperability. I'm glad that MathWorks has it, MATLAB has it. And I think it's something that any platform, when you have it, can help you leverage fast moving times around you.
I think that's a great tip. I really think that that's so key because, a lot of times, and I think the way I'd frame it, kind of saying it back to you is your platform team needs to think about what gets done on the platform and very intentionally think about what doesn't get done on the platform, right? And how the platform can support both, right? And what doesn't happen on the platform, you support through interoperability, interfaces, and I guess all those things that we talk about and sort of like API engineering and in terms of just making your tool play well with other use cases that it may not necessarily directly, enable, but it needs to kind of support.
Yeah. I'll just sneak in. I was the product manager for the MATLAB Python interface.
Oh yeah.
As an example. Yeah, but go ahead.
Yeah. I mean, that's really cool. And I think that lesson, this notion of interoperability, I think it's very helpful to hear as being, one of the things that platform teams need to take into account for their ultimate success. Because I think, we're also seeing actually a lot of efforts that try to replicate this through groups like the AI Infrastructure Alliance and other, we had on a guest the other day from Alex Chung from Social Good Technologies, where they're trying to create sort of a similar sort of what they call a control plane for MLOps. It seems like people are trying to adopt technical standards, but teams would also be well served to have their own sort of product standards for what their interoperability looks like.
Yeah. And also, speaking of interoperability, I should mention that it's not interoperability per se, but at Pinecone, we support these different engines for ANN, and it just makes sense. We don't want to lose innovation. Like if there is some edge that Face has, then we want to offer that to our customers. And if there's some advantage that HNSW, and I think that speaks to why we didn't put all our eggs in the basket of our own proprietary ANN engine, and we want to leverage the things that are going on in the ecosystem.
Yeah, it's actually it's great that you brought that up, because I was going to ask you. You talked a lot about platforms generally, platforms at MATLAB, and now you've told us about platform. How Pinecone thinks about it, and I think I'm just kind of curious. How do you see the vector search ecosystem evolving? You've talked a little bit about the other engines that are out there. You are the first managed service that helps pioneer this. What could be a very useful toolkit, for ML teams going forward. How do you see this sort of subsector of the industry evolving going forward?
Sure. I think something I've realized coming into the industry is how complex these solutions can be, and how much we, going back to when we were discussing what goes into it, that we tailor things a lot for enterprise customers. And it surprised me a little bit how much, but every use case is different, and every use case, we can optimize things a little different. And so I think that, the libraries, I expect, will continue to grow and advance, and there'll be a research community around them. I mean, it is active research right now. And so there's improvements happening all the time to these libraries. And so I think that's one advancement that we'll see, is a continuation of that people are going to keep investing in these libraries at a research level. And then on a production side and bringing it to production, I think you're always going to have companies like Facebook, Google, Amazon, who are going to do this on their own because they recognize the benefits of tailoring. And they're going to put the investments in place to do this, as complex and as challenging as it is. But then there's this whole world of companies that could benefit from a Pinecone, right? Who does this for them, and who doesn't want to build out the team, the effort, the expertise that's necessary to become really good at this. And they can kind of amortize that through us, right? Because we work with many customers. And so I wouldn't be surprised to see that there's more companies like Pinecone that kind of rise to fit this need. I don't know that Google has a solution as well, and I want to, I'll mention that. The thing is, I think that what I'm realizing is that with the need to tailor solutions to use case, I don't know that we'll see one kind of solution that fits all. I think that we're still going to live for quite a while in a space where optimization really matters, and optimization really can cut compute costs. And that creates room for players like Pinecone. If that answers it.
That absolutely answers it.
Yeah,
I
completely
almost didn't expect that level of complexity to delivering the solution, but that's what creates the need for multiple different players, and kind of why the ecosystem is where it's at, right? And so with that, thank you so much, Dave, for joining us on the podcast, for catching up with me, an old friend, and telling us all about what Pinecone is doing. This discussion was a lot of fun. It got technical, but it stayed high level. It kind of hit that balance that we like. So thank
for me
you so
too.
much.
Yeah, I had a lot of fun as well. Great talking.
Yeah, super nice to learn about what you all are doing, and also your road or your journey here is really interesting to hear about.
Cool.
And we definitely need that picture of Zeus. He's dangerously cute.
Yeah.
And I'll also say, great job with the podcast. I am an avid listener, and I love all the episodes you guys put together. So,
Nice.
Honored to be here.
Thank you. All right. And we'll see you on the next episodes of MLOps Coffee Sessions. Thanks for listening.